What we're going to do here is recreate in a qualitative way one of the classic experiments in physics. This was one done by J.J. Thomson in around 1897. But there are various bits of electromagnetism that go into this experiment, and I want to talk about those. So the basic setup is in fact a little bit similar to the cathode ray tube that we talked about earlier when we were talking about the oscilloscope. This device has an electron gun at the back here, so a cathode. The electrons are accelerated, and the anode voltage is a few thousand volts, and they then pass through this, and instead of hitting a screen at the end, you can actually see the electron beam as this very fine blue line along there. Now, the apparatus has in fact two parts. There's an electrostatic deflection, plates in here, which act in a very similar way to the way they do in the oscilloscope, but we've also in this case added a magnetic field. These are known as Helmholtz coils. It's effectively a solenoid which produces a fairly constant magnetic field in the center, and we're going to adjust all of those separately. Before I do that, I want to show a much cruder way of doing this. This is a permanent magnet, and you'll see that when we bring the permanent magnet up to the beam, we can in fact deflect the beam, well, downwards in this case, and so if I flip the permanent magnet round, it will deflect the beam upwards. So this is not a very systematic way of doing things, but obviously I can produce a deflection that way. The Helmholtz coils produce the deflection much more systematically. So what I'll do in this experiment is firstly to turn on the electrostatic deflection, and you'll notice in this case the beam will start moving downwards like that, like so. And so in this here we've managed to deflect the beam downwards. The physics is exactly the same as the physics of the oscilloscope. The beam is accelerated by the anode and deflected by the plates. So I can turn that back to zero deflection. I can also produce a magnetic deflection. And the magnetic deflection now is produced by those coils, and by adjusting the current in the coils, I can increase the deflection of the beam. So the way Thomson did the experiment was to start off with no deflection, put on a deflection due to the magnetic field which would bend the beam upwards, and then put on a deflection due to the electrostatic field which would bend the beam downwards, and we can end up with an undeflected beam. We can in fact calculate the velocity of the electrons, and you'll see this in a few minutes, by measuring the magnetic and the electric fields. That gives us the velocity, and from this in turn we can actually work out the ratio of the charge on the electrons to the mass of the electrons that make up this beam.